What's good, everyone? My name is Czar Char, and today I have a banger of a tutorial for y'all today. Long story short, a crosshair that actually represents your weapon spread. A lot of crosshair tutorials right now talk about how to either have just a static image up there or how to change the weapon spread while moving, but they don't actually explain how to dynamically change the weapon spread on the crosshair whenever you're shooting. And also, if I were to change the basic weapon spread, because maybe I swap to a different weapon, then that new weapon spread gets accurately stimulated. So now the weapon spread starts off a lot larger, and then if I were to maybe swap to a more accurate weapon, then as you can see, the spread is a lot lower. So the system is very modular, and without further ado, let's get into it. Alright, so as I said in the intro, we have two parts in this video. The first one is the shoot system, and then the second part is the actual reticle system. So if you don't have a shoot system set up yet, you should probably watch this first part of the video so that way you also get that implemented as well. But if you already do have one implemented, the only thing you need for the reticle to really work is a way for you to track your dispersion of your weapons, so in degrees or radians, but I'm going to be working in degrees, so make sure you transfer anything that if your system uses radians, make sure you transfer anything that I have in degrees to radians. But long story short, if you already have a shoot system, go ahead and skip to this timestamp currently listed. But if you don't, stick around for this first part of the video, and then we'll get into the reticle part. So I'm in the first person template right now, and right now the way it works is I can move around my camera, and I have a gun that always shoots directly at the center of my screen. But unfortunately, it also shoots a projectile. So we're going to make this a hit scan system. Of course, this reticle system also works with projectiles, but I just want to quickly make a hit scan system so that way we can get the tutorial on the road. So the first thing I'm going to go ahead and do is I am going to go into first person, blueprints, and inside BP underscore rifle weapon component, I believe, if I am remembering. Yep, there it is. Yeah, so real quick, the way the first person template works, in case you didn't know, is that things are isolated into components and logic is isolated into components. So that way, when you start playing the game, you can't shoot until you pick up the gun. So the first thing we're going to do is we're going to open up BP underscore weapon component. And when we open this up, we'll see that we have our input action shoot right here. And what it does right now is it spawns a projectile, and then it does all this logic. We're going to go ahead and delete this because we're not going to spawn a projectile, we're going to do a ray cast. So the way we do that is from triggered, we drag out here, and then we type in line trace by channel. And then boom. So now what we have to do is we basically need to define a start and end point. And the way we're going to do that is, first off, we're going to get rid of this make transform. And we're going to, from this, get camera rotation. So based off the player's camera rotation. We then get a forward vector, so type get forward vector, and after we get a forward vector, we're then going to right click in the graph, type in cone, and then select random unit vector in cone in degrees. We then, for cone direction, feed the forward vector we got, and what this function does is it creates a cone based off an angle, and with the top angle being whatever you input here, and then it just gets a random vector that's in that cone, and it returns a directional vector, which then we can do things with. So we can multiply this by however much to kind of like do as like a weapon distance as an example. But this is kind of the basis of our dispersion system. So now that we have that, the next thing we have to do is we have to define a half angle. And what a half angle is it's basically if you were to make the cone and squish it into a triangle and then cut it in half, what is the angle at where the cone or where this triangle is beginning to be drawn? And then we're just going to call this weapon half angle. And this is our dispersion right there. And we're going to do stuff with this variable in a second, but first let's just go ahead and give it a default value of 5 degrees. And then let's go ahead and get our line trace working. So the next thing we're going to do, we're going to go ahead and get the player camera manager. And we're going to go ahead and get the camera's location. Next, we're going to drag out from the return value and input that into the start node of the line trace. Next thing you want to do, you want to get from get camera location, you want to get an add node, and from this add node, we're going to drag out and we're going to get from the open pin, and we're going to get a multiply node. And what we're going to do in this multiply node is we're going to feed this random unit vector in cone in degrees into one of the inputs, and then the other input we're going to right click it, and we're going to convert this to a float double precision, and then this will be our weapon distance. So go ahead and promote this to a variable and call it weapon distance. And what this does is this is just a very simple rake. And then once we get, sorry, but I'm getting ahead of myself. Before we do that, this little addition node we created earlier, you want to drag that to our endpoint. So what this does is what we're for the endpoint, what we're doing is we're calculating a random unit vector in degrees based off a direction, and our direction is whatever our rotation of the player camera is, and then we rotate that slightly based on a random direction inside a cone, and that cone is defined via half angle in degrees. And then once we have that, we then multiply. This will be a unit vector, so the sum of each of the parts of the vector will equal 1. And then we just simply multiply that by however much our distance is. And then we add that vector to our camera location. The reason why we add it to the camera location don't just feed it to the endpoint is because the endpoint is a position in the world. And if you were to just simply say, hey, I want to I'm going to take this multiply and put it into the endpoint, well then that position in the world is probably going to be 500 feet behind the player. It's not going to be where we want it to be. So we have to add our calculated endpoint to our start point, so that way we get an accurate endpoint. So once we do that though, we've pretty much done everything we need to do. All we need to do left just for debugging is to change our draw debug type to for duration, compile this, save this, and let's see how this works. So, hey, I just realized I forgot to set a weapon distance. Make sure you set your weapon distance. So let's change this to 2000, so that way there is actually a line trace. So yeah, we're going to have a weapon distance now, and what we're going to do now is now that we have weapon distance, go to level, you'll see we'll have random traces. We have this nice little dispersion in a cone. So yeah, now from the camera you can't really see it that well because it's tracing directly from the camera, but if you look towards the side, you'll see that this dispersion is very random. And if you look at it like this, you see that we have a nice dispersion. Great. So we've just created our dispersion shoot system, and there's a distance. Alright, so the next thing we need to do is we need to create our Crosshair UI. So to do that, let's go ahead and go back into our blueprints folder. The first thing we're going to go ahead and do is go to user interface, widget blueprint, create a user widget. So just call this widget blueprint, so WBP underscore, I'm going to call it UI since this is the only thing I'm going to UI in my project. I'm going to open this up. We're going to get this blank screen. First thing we want to do is we want to get a canvas panel. This allows us to effectively place. This is just a nice little panel that lets us place anything in here freely, and it's going to be very important for us to use, and you'll see why. Next thing we're going to do is we're going to get a bunch of borders. So we're going to get a border. We're going to call this center. Next, after we get this border, we're going to get our anchors, and while holding Control on your keyboard, press this middle anchor. And then after you do that, the next thing you want to do is you want to set your alignment to 0.5, 0.5. This will align the center of your reticle to the dead center. So next thing you want to do is just tone down the size to say, something reasonable. So maybe like 5 by 5, something that isn't going to obstruct the player too much, but is visible as, oh, this is the center of the reticle. So we'll get into the spokes in a second, but first, just so that way we can get some setup out of the way before we go into the logic of how we get the spokes to dynamically change, we're going to quickly go back into we're going to go into our event graph, and we're going to go ahead and go in variables. We're going to add a variable. We're going to call this player ref, and its type is to make it whatever your player blueprint is. In my case, it's going to be BP underscore first person character. And then what I want to do is I want to make this public and editable on each instance of the blueprint, so it's instance editable. And then after that happens, I want to check expose on spawn to be true. Next thing I want to do is I want to open up my first person character. So on event begin play, what I want to do is I want to go ahead and I want to create widget, and it's going to be of type widget blueprint underscore UI, and the player reference is self. The player reference is going to come in handy for when we're trying to get the spread of the weapon, and you'll see how we're going to do that in a second. The next thing we want to do is after you get that, we just want to add this to viewport, and voila, just like that. If we go back to our main game, we now have a reticle centerpiece that our spread is somewhat around. Obviously, if we were to if we go back into our weapon component and change our half angle to 0, then every single line trace will be dead center on the reticle, which is perfect. And that's what we want. But obviously we want dispersion, so let's go ahead and get our half angle back to 5. Now, if you already have your shoot system set up and you skip to this part of the video, make sure you have some variable somewhere in your shooting system that can track the dispersion of the weapon, and preferably this is a float. So just make sure that you have a variable that can track that, because we're going to do something with this in a second. So the next thing we want to do is we're going to go back to the designer, and now we're going to duplicate this, and we're going to call this left, and then we're going to duplicate our left, and we're going to call this right, and then we're going to duplicate this again, and we're going to call this bottom, and then we're going to duplicate this again, and we're going to call this top. So now we have multiple different we now have multiple we have all the spokes of our reticles. And just as something real quick, make sure that the alignment is anchored. So make sure you just click, you go open up your anchors, hold control, and you press and you click on the center, because they will be out of alignment whenever you create them again. So make sure you just go through and do that. All right, the next thing we want to do is for bottom and top, highlight both of these. And what we want to do is we want to set our offset right to be 2. And we want to set our offset bottom to be 6. And what this does is this creates a spoke that's pointing up and down. And then for left and right, we want to highlight both of these. And for our offset right, we want to set this to 6. And for our offset bottom, we want to set this to 2. And this gives us a spoke that's more left and right. So yeah, there we go. And now that we've done that, we're going to move on to the next thing. So I'm going to do this off event tick. If you want this to be more efficient, I would recommend creating a custom event that you call every single time the reticle should change its dispersion rate. But for simplicity of this tutorial, we're going to do this on event tick. And what we're going to do is we're going to get our player reference, and we're going to go ahead and we're going to get for my case at least, because this is inside a component, I'm going to get component by class. And I'm going to call this BP underscore weapon component. And first off, because this is a component, this is just something that you have to do if you're following along with me through the first person template, is you're going to have to check to see if this is valid. Because there is the scenario in which the player doesn't have the weapon, in which that case you don't want to do anything, because then this is going to throw a bunch of errors. But the main reason why I'm doing this is because I want to get that dispersion variable. So what I'm going to do is after I get that, I'm just going to get weapon half angle. Great. So now I have the weapon half angle, and this is going to come handy real soon, and you'll see where we're going to do this. So the next thing we're going to go ahead and do is we're going to go ahead and calculate our spread. So to do that, let's go ahead and make a function so that way everything stays clean. So we're going to call this calculate spread. So what we're going to do is we're first off going to get an input, and this input is the half angle, type of float, and here's what we're going to do. So if you can remember from high school geometry, you've probably learned a lot of trigonometry. And while learning trigonometry, you might remember how you can calculate missing side lengths and missing angles using sine and cosine. And one of the scenarios in which you are capable of calculating the missing sides and angles is if you know two angles and a side. Luckily, in our case, we can do that. So remember, if you were watching if you were watching how to create the spread system earlier, you remember that the function we used effectively created a cone and then found a random direction in that cone, and then basically we had a unit vector from there. So again, if we squish this cone, we get a triangle. So if we squish the cone, we get a triangle that's a 2D shape. Now here's the thing. What we can do is if we were to take that cone and go from top to bottom, the edges of that triangle outwards is our spokes in the crosshair. And the same thing applies if we were to go left to right. Our triangle is the spokes of the crosshair. And here's the thing. Because we're not making a Titanfall 2 crosshair, our spread is even across all sides. There is no, funny, our spread, the maximum spread on the right side of the screen is greater than the maximum spread on the left side of the screen for whatever reason. Our spread is even across all sides, so because of that, we only need to calculate one triangle to get the spread, to figure out how much we have to spread the spokes along the crosshair along the screen to accurately represent the spread in the game. So to do that, we can simply take our squished triangle and cut it in half, because that will basically allow us to calculate for one spoke, and when we do that, we have a right triangle. So we know the angle, and also we know our half angle. So because we know our half angle, and because we know one of the angles is a right angle, or 90 degrees, we can then calculate our final angle, and then we can calculate for this side right here, which is perfect. And that's precisely what we're going to do. So let's go ahead and create 3 local variables. We're going to go ahead and create one variable called angle A. Type float. Let's go ahead and put that in here. And angle A is going to be the half angle. Then angle B is going to be 90, because this is our angle. This is the other angle we know. So angle B will be 90 degrees. So let's go ahead and plug that in right there. And then finally, we'll have angle C, or the third angle that we don't know. But luckily, because we know the other 2 angles, and since all the angles in a triangle add up to 180, well then all we have to do is have a subtract node, and all we have to do is do 180 minus angle B minus angle A. And that'll calculate for us angle C. So that's our first part of the function. The next part of the function we need to do is, since we know an angle, and a side, well, we need to figure out the side. Now, if we go back to our triangle, we have a straight line straight across from the player, and that is the weapon range, or just a default range. And because of that, we can just simply simplify this to a number that we think should be the default range across all the weapons. So for example, if you want to have the reticle to represent a spread of the weapon at 20 meters, well then this side would be 20. So in this equation, what we're going to do is we're going to create a new float. We're going to call this side A. And since I want side A to be 20 meters, then in Unreal units, that's 2,000. So we're going to go ahead and make this 2,000. So side A is 2,000 units. Because of that, we now have angle, side, and we can do a calculation based off of this. So in order to figure out this side of the triangle, which is effectively indicating how far along do we have to push our reticle to the side in order to give an accurate spread, all we have to do is we just need to calculate, we need to get the sine of side A, or sorry, the sine of angle A and the sine of angle C, and divide them over each other. So the way we do that is we just simply get angle A. Since I'm calculating this in degrees, I'm going to drag out of this and I'm going to get sine in degrees. And then we're going to get angle C. And then we're going to drag out of here. We're going to go ahead and get sine in degrees. And then we're going to divide this. So we're going to go ahead and divide these two together. This, in a sense, gives us a unit. And what we want to do now is we then want to multiply this, since we now know, the side, one of the sides. All we have to do now is we just have to multiply this by side A. And after we multiply this by side A, we're then able to calculate how far along that line is. So the next thing we want to do is we just want to go ahead and add a return node at the end here. So drag out of side A, and we just want to type in add return node. And then we just want to drag here, put that into there. And then we just want to call this return. And boom, you just did some trigonometry. But this will allow us to dynamically move the crosshair based on how the half angle works. Because if in your code you have the half angle constantly increasing because of the player constantly shooting, well then that is going to be represented here, and then we just do this nice little calculation using angle, angle, side, and some trigonometry, and then we have our spread. Now, just as a little bit of a tidbit, if you wanted to have a dynamic crosshair that also took into account what is the maximum, like based on where the player is aiming, what is the maximum range of that where the player is aiming, and then adjust the crosshair to be like that, or maybe you have an in-world crosshair and you wanted to adjust the crosshair size to be based on like where it is in the world, well then all you would have to do is from side A, you just put this in as an input, and then you would just simply say distance, because all side A is the distance of the shot. So if you want the crosshair to represent the distance of the shot at 20 meters, then you just hard code in 2000 as side A. However, if you wanted to be more dynamic based on like where the player is aiming, or maybe you have an in-world crosshair, then just simply make this into an input and calculate spread. But yeah, that's this function in a nutshell. Now that we've gotten that done, pretty much all we're going to do now is we're going to drag calculate spread, put it inside of a tick, and then we just simply feed our half angle into calculate spread. Now, if for whatever reason in your shoot system you don't have a half angle, but rather you have a full angle, then what I would recommend is just all you have to do is just divide this by 2 and then feed that into there. Now that we have that though, the next thing we need to do is, before we continue down this line, we need to go back to our designer, and we need to highlight our left, right, bottom, and top. We need to get all of these, and then we need to make them variable. Because what this will allow us to do is this will allow us to modify them inside the blueprint editor, which is what we want to do. So let's start off with getting our bottom crosshair. And what we want to do is we want to slot this as a canvas slot. So just type that in, slot as canvas slot. And what this does is this allows us to manipulate this UI object inside as if it was inside a canvas slot, which we know for a fact it is because it's inside a canvas panel. So what we're going to do is because this is the bottom one, we're just going to set our position. So we're going to type in set position, and boom, we now have our position. So what we're going to do is we're going to split the struct pin. Then we're going to drag out of the return node and put it in position Y. The reason why we're doing that is because in our designer, our axes are inversed. So if we look at our graph editor, or sorry, our designer, if we add more to our Y, we're actually moving down. So because of that, we're not going to multiply this return by -1. We're just going to feed it straight into the Y, because it's just going to move down if it's positive, and it's going to move up if it's negative. And we're going to do the same thing with our top. So we're going to drag out our top, slot it as a canvas slot. And then we're just going to drag out set position. And then split the struct pin, get a return, multiply it by -1, and then set that to our position Y. So now if we go inside our editor, once we pick up the weapon, we now have our top and bottom crosshair, and they accurately represent what the spread is at 20 meters. And if you wanted it to, and if you go back in here inside the calculate spread, and we change this maybe to only 10 meters, so this would be 1,000, well then what you'll notice is the spread itself is going to look a lot smaller. That's because it's only accurate up to 10 meters. So usually what game devs will do is they will try to make it a much larger number than a smaller number, simply because, engagement ranges vary, but, it's always better to have accurate values for longer ranges rather than shorter ranges, because if you are at a shorter range and you are right next to the edge, obviously you will see that the spread is a lot more contained than it usually is. But anyways, if we go back to our UI, and let's go ahead and set this back to 2000, let's go ahead and quickly get our left and right crosshair set up. Let's go left, drag it out, slot as canvas slot. And what we're going to do here now is, because these are our left and rights, we're going to go ahead and set our position. And we're going to modify our X instead of our Y. So our Y isn't going to change, it's now going to be our X. So split the structure pin, and we're going to get our return. And real quick, I want you to go ahead and guess in the comments, what do you think, which do you think left is positive or negative in terms of a value? Let's see here. Left and right in this coordinate system is negative. So because of that, what we're going to do, since this is our left, is we're going to go ahead and get our return. We're going to multiply it by -1, and then we're going to feed it into position X. So multiply by -1, feed it in position X, boom, perfect. And we're going to do the exact same thing. We're going to go ahead and get the right, slot it as a canvas slot. And then what we're going to do is we're simply just going to go ahead and set the position, plug it in, split the structure pin, and then drag out a return node, put it into a position X. Compile it, make it look neat, and save. And then once we go over our gun again, boom, we now have our spread. But as you might notice, right now it doesn't dynamically change, and that's because on my system I haven't set up a function to dynamically change the spread. So let's go ahead and do that just as a quick example. So what I'm going to do on my end is I'm going to go ahead and open up my input system. I'm going to input actions. We have input shoot, and I'm going to quickly remove the trigger that requires it to be pressed, because I want this to be constantly firing. So I'm going to go to BP_weapon component, and the next thing I'm going to go ahead and do is I'm going to go ahead and add a weapon. I'm going to add base weapon half angle. And what I'm going to do is an event begin play after I do all this stuff. I'm then going to go ahead, I'm going to change this to float real quick. What I'm going to do is I'm going to get the base weapon half angle, and I'm going to set the weapon half angle to be the base weapon half angle. And the weapon half angle is where I'm going to take care of what should be the quote-unquote like base half angle. And for now I'm going to put this as 3. And then the weapon half angle represents the actual half angle that the weapon's at. So what I'm going to do here is inside our input action shoot, what I'm going to do is every single time I shoot, I'm going to get the weapon half angle, and I'm going to add 0.1 to it. And then I'm going to go ahead and set weapon half angle to that. Once I have that done, the next thing I'm going to go ahead and do is I'm going to add a do once node to triggered. And the reason why I'm doing that is so that way I don't just spam. I don't have like one bullet per tick of the CPU. Instead, I have an actual stream. And just to do that, I'm going to quickly create weapon RPS, which stands for weapon rounds per second. And all weapon RPS is going to be is, let's say it's going to be 5 rounds per second. So we basically are going to shoot once every 0.2 seconds. Down here, we're going to add a delay. And the duration is going to be the weapon rounds per second. And we're going to do a division statement. And it's going to be 1 divided by the weapon rounds per second. And then once we get done with this delay, we're going to go back to this do once node and reset it. And we're going to quickly open up this drop down for the input action. And whenever this input action has been completed, we want to go ahead and do is we're going to go ahead and call another custom event. So we're going to go down here and we're going to add a custom event. We're going to call this reset spread. So then in reset spread, what we're going to do is we're going to set the weapon half angle, and we're going to go ahead and subtract. And before we subtract, actually, I'm going to go ahead and clamp float with the maximum value, make it like some really large value that's insane, but the minimum should be our base weapon half angle. And this is going to make sure that we don't reset our spread below the base weapon half angle. And our value is just going to be our weapon half angle minus, let's say, 0.2. And we're going to do this every 0.1 seconds, so then add a delay. And we're going to do a quick branch statement. And if the weapon half angle is equal to the base weapon half angle, then we're going to do nothing. Otherwise, we're going to go ahead and we're going to call reset spread again. But also, as another thing of note is that we're going to do an AND statement, or we're going to do an OR boolean. And what we're going to do is, first off, we check to see if our spread is reset, or if IA underscore shoot is being triggered. And if it is, then we don't want to reset our spread. And what this is going to do is, if we go over our thing, we're going to constantly be shooting. I'm currently holding down my mouse button. And then it's going to constantly lower our spread. And voila. Now, obviously, this is probably not how your shoot system is going to work. I just did this for example purposes. But this is how this is just a dynamic spread system. Obviously, yours is probably going to be a lot more accurate. But yeah, this is the UI widget. It accurately shows the spread going more further out, and then it shows it going back, and then it collapses. And all of this is dynamic, and it's accurate to the reticle itself. So yeah. I hope this was very helpful for you. There's a lot of tutorials talking about reticles, but they don't actually talk about how you can show accurately the spread of a weapon. So hopefully this tutorial helped you out. If it did, please give us a like. I'd love to do some more UI tutorials because I really do like doing UI programming, and I can talk about how to do some dynamic UI. I could talk about how to do some runtime manipulation of UI elements. I'd love to go through some tutorials of that. So if you like this and you want to see more of this, give this a like. If you want to see more tutorials that you don't usually find on YouTube, please just go ahead and give me a subscribe, because I'm going to go ahead and I got a lot of tutorials. I'm currently cooking up. There's a little more bigger one, an omnidirectional gravity switching tutorial, and that's going to be very interesting and very fun when it comes out. I'm currently trying to cook it up to make it look good and actually function properly, because right now it's pretty janky. But when that comes out, I'll be more than happy to show you. Otherwise, thank you so much, and you have a great one.